Hello scholars, welcome back. Mr. Hinkle here. Today's lecture we're talking about ore deposits, or another name we could call this would be metallic mineral deposits. Because mineral deposits are divided into two types. Metallic and non-metallic. You can check out my non-metallic for the discussion on the other type, but for this discussion we're talking about metallic, which in more common terms we call ore deposits. So the purpose of today's lecture, introduce and understand ore deposits in the context of natural resources, because they are natural resources, discuss how ore deposits form, the various types of ore deposits, and then we will briefly touch on the environmental concerns regarding ore deposits. So, ore deposits are concentrations of economically valuable minerals that can be mined for a profit. Now, part of this is that they not only are minerals, but they are minerals that contain metals, which in turn makes them metallic mineral deposits. Through geological processes they form, which we'll discuss. They're crucial in the mining industry, and there are very specific conditions for their formation, like the banded iron formations that we see here that developed when there was a lot of iron in the oceans. The atmosphere oxygenated, that iron oxidized in the oceans and deposited on the bottom of the ocean, which then, millions of years later, was transferred, uplifted, shoved up onto the continent, and became the basis for the iron that fed the steel revolution in the United States. It's amazing how intertwined minerals and ores are with the big leaps of human civilization. So, a little side story there. An ore deposit. So, we have a mineral resource. There's a copper resource, right? And so this is how much copper that we know right now is in the world. Now, how much copper that we know is available in quantities that we can harvest, that we can mine, this is the proven reserve. And in order to mine the proven reserve, we need technology, we need economic conditions, and political, social, and environmental considerations. So the price has got to be right, and the technology has to be available in order to pull these proven reserves, these ore deposits, out of the earth and turn them into a profit. Now, there's what we know, resources, there's what we can harvest for profit, reserves, and there's undiscovered resources, which could in turn increase the amount of proven reserves that are out there. But we don't know what we haven't found yet, but the earth is still, it's pretty big, so at any point we might be able to expand with these undiscovered resources that are out there. The process goes like this. So copper, for example, we don't often find native copper just in large concentrations all by itself. In fact, we have the metal copper that is mixed in with a lot of other components of the rock, and we call these components gangue. Now, in order to separate the copper from the rock that it is found in, we go through the process of physically separating the gangue from the ore-bearing minerals. This is concentrating. We concentrate the ore deposit, because in the ore deposit, it's all there. We've got the metal of choice, we've got the less desirable minerals that are in there, and we need to concentrate in order to remove the materials that we don't want. So let's go through here. I will grab my purple pen. So we have an ore deposit. We've got the ore that we want with less desirable components that we first move through a process of concentrating. This is to remove, get out of here gang, the unwanted materials. Then there's a metallurgical process that we extract the metal ores, converting them into a purified metal, and this is called smelting. This is going to concentrate and give you the substance that we can then take to market. If we need to purify it a little bit more to a higher quality or composition, then the last part of this process is refining. Ore deposits are minerals that are in Earth's crust. They're mixed with other undesirable minerals that we want to get rid of. So through the process of concentrating, smelting, and refining, we can create a high quality, pure metal that can then be used for the whole variety of desirable effects and uses that we have for that specific metal. So where do these ore deposits come from? How do they even form? Well, there's 4 specific ways: magmatic processes, hydrothermal processes, sedimentary processes, and also metamorphic. Oop, I guess I forgot the processes there. Here we can see an iron ore that's interbedded with a bunch of other minerals. It's been deformed in these really cool, tight chevron folds that are in it. Awesome. Lots of colors, very beautiful rock. Minerals crystallize from magma or lava. This is how we form igneous rocks. Some ore deposits will actually form in that crystallization. There's a process for igneous rock development called fractional crystallization, where you vary the concentrations in the melts. Within this, the concentrations can vary such that what is remaining will produce ore deposits, which are then later discovered and mined out of the earth, and they go through this process, boom, 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 in order to be available for use in market. In the bottom of the ocean, there are cracks and fractures in Earth's crust that can be superheated from Earth's internal heat. That hot water, excuse me for a moment, excuse me, that hot water then will move through mineral veins and it will precipitate out when it cools. When it mixes with that cool ocean water, it will take all of those dissolved metals and it will precipitate out to give us gold, silver, copper, various metals in the bottom of the ocean. So hydrothermal, if we break that word down, hydro means water, thermal means heat. So when hot water carrying dissolved minerals cools, it will precipitate out these ore deposits. Sedimentary deposits. This is the deposition of minerals. What I explained earlier for banded iron formations, this was a sedimentary process. So iron that was in the ocean oxidized and deposited at the bottom of the ocean. So if we make a list, we've got magmatic, hydrothermal, sedimentary, and so this is going to be minerals that deposit. Many minerals deposit, rocks deposit, but when certain metals accumulate in these sedimentary rocks, this is the sedimentary process of developing or creating, forming ore deposits. Metamorphic processes. Okay, so basically what we've gone through are igneous rocks, sedimentary rocks, and metamorphic rocks are 3 main types of rocks, earth materials, that are distinguished by how they form. Form from magma, form from deposition and lithification, and then our last is metamorphic. And since these are our three main rock types that create minerals, they are also the three main ways, including hydrothermal in addition, that will create ore deposits. When pre-existing rocks undergo heat and pressure, they may change their mineralogy into creating new minerals. This is the basic premise of how metamorphic rocks are created. Well, sometimes these changes in pressure and temperature can lead to the formation of economically viable ore deposits. So the rock cycle and earth materials and processes that are happening within Earth's crust can lead to the development of ore deposits. Different types of ore deposits. Well, layered intrusions and pegmatites, these are both going to be magmatic. Layered intrusions, these are going to be when lava injects itself lengthwise or cuts across and concentrates the elements. Pegmatites are going to be when solidifying magma interacts with water. That can change the chemistry, creating ore deposits. Porphyry deposits and supergene enrichment, these are going to be from weathering that have to do with sedimentary rocks. This occurs when deposited minerals change their form when they are uplifted, eroded, and exposed to the elements, often to oxygen, because oxygen creates the oxidation process, which can then change minerals from one form to another, thereby leading to ore deposits. Skarns are when we have a specific type of rock, calcium carbonate, in the form of limestone, that reacts in order to produce calcium, magnesium, silica-rich minerals. Again, this is the main processes for the rock cycle: heat, pressure, nearby magma, weathering, and water, creating various types of ore deposits. Placer deposits form as a result of hydraulic sorting from water. So basically, rivers can concentrate high-density grains of specific metals into these depositional environments, which can then be sorted through and mined. For instance, gold panning, sluice boxes, or hydraulicking, which were the common forms of looking for gold during the gold rush in order to locate and extract these specific mineral deposits. So placer is another way that ore can collect and deposit. Okay, so what are the impacts of ore minerals? Well, whenever we concentrate metals, anything in a large dosage can be toxic. Even water can be fatal if a human drinks too much. But the process of extracting ore deposits, which is called mining, and then transferring the ore deposit into a refined product can leave waste products. And the waste products are often contain the mineral pyrite, and when you can concentrate pyrite into waste ponds, it turns into a very acidic product, which leads to acid rock drainage. This is the big thing. So mining a bunch of ore, you mine the ore, and then process, refine, concentrate. All the leftover materials, they need to go somewhere. Well, those waste ponds full of the leftover materials, high in pyrite, mix with the oxygen in the atmosphere, and then mix with the rain when it rains, creating a very specific type of drainage called acid rock drainage. This is not good. And so what do? Well, we need to have responsible mining practices, environmental regulations that are important for mitigating these impacts, because the world runs on minerals. Metallic minerals, powers our technology. Non-metallic minerals, it builds our homes and our industry. We need these as a society. Minerals are extremely valuable and important. And we get the minerals from the earth. Let's go to the conclusion. We get these minerals from the earth through geologic processes, and we will continue. So, having sustainable resource excavation will minimize environmental impacts so we can continue to mine, we can continue to live, and we can reduce the amount of impacts that we are having on our earth because it is the only one we've got. Thank you so much. I'll see you again.